Simmon-Smith is important organic reaction which is used for transformation of alkene into a cyclopropane system. In other words, we can say that this reaction is used for making a cyclopropane system or cycloalkanes, especially with three-membrane system. Consider a reaction. We have a cyclohexene and we are going to react it in the presence of diiodomethane and zinc copper couple. We get a new system that is bicyclic in character. Here we have two hydrogen. The molecule is known as norcorane. This type of reaction is known as insertion reaction. We call it insertion reaction because we have inserted a methylene group across the double bond. So such type of reaction is known as insertion reaction. Basically, when diiodomethane is reacted with the zinc copper couple, we get an important organometallic compound which is known as Simmon-Smith reagent. This reagent is known as Simmon-Smith reagent. And it is carbonide in character. We call it a carbonide because it has the potential to generate a carbene. All those compounds which have the potential to generate a carbene are known as carbonides. So we will check out how a carbene is generated. Let's focus at the structure. This is a Simmon-Smith reagent or organozinc compound. Usually in organometallic we have a reversal of polarity. If we consider alkyl halide, a halogen atom has a partial negative and a carbon atom has a partial positive charge, unlike Grignard reagent where we have partial positive and partial negative. So here in normal alkyl halide, the alkyl group is electrophilic in character, but here it is nucleophilic in character. When we bond a metal such as magnesium or zinc or copper or lithium or any metal, when it is bonded to an organic molecule, this new sort of compound are known as organometallic compound, which is an interesting area of organic chemistry. So in organometallic usually there is a reversal of polarity. Which we call as unprolonged. So metal usually donate electron. Just consider right over here the organozinc compound break like this. We get a carbonyl, and the second step, the halogen atom leaves from the molecule and we get a new system which is known as carbene. This carbene is electrically neutral species. It is electron deficient because it has a deficiency of 2 electron from octet completion. Here we have just 2 bonds, 2 hydrogen. It can be 2 hydrogen. We can have 2 halide atoms such as Br, which this is known as a diabromocarbene. It can be a bromo or chlorocarbene. This is a methylene carbene which we have generated right over here. So all these species are electron deficient, and they act as electrophilic reagent, which aids to the double bond in Simmon-Smith reaction. Just if we focus on the geometry of carbene, the carbon atom is sp2 hybridized. This carbon atom is sp2 hybridized. We have one unhybridized p orbital as well, which lies perpendicular to the plane formed by the 3 sp2 hybridized orbitals. So this is unhybridized p orbital, and the lone pair of electron is present are in sp2, one of the sp2 hybridized orbital. So as a whole, the geometry is sp2 hybridized. As far as carbene are concerned, they act as an electrophile and nucleophile. They can act as both electrophile and nucleophile. Carbene acts as electrophile and nucleophile. Usually it acts as a electrophile due to presence of an unhybridized p orbital, which make it electrophilic in character, and as far as the lone pair of electron is present in one of the sp2 hybridized, it make the carbene as a nucleophilic. As far as stereochemistry is concerned, so Simmon-Smith reaction is highly stereospecific. For example, if we have the starting alkene of one configuration such as cis, so in the presence of diiodomethane and zinc copper couple, we will get a cis cyclopropane system. If it is trans, we will get a trans product. For example, just take an example. Again, we will get a trans. This is cis cyclopropane, and this is trans. So on account of this feature, we say that Simmon-Smith reaction is stereospecific. We call it stereospecific because the CH2 or carbene add to the double bond simultaneously. So as a result, the stereochemistry is preserved. So this is all about a simple Simmon-Smith reaction, which is an important class of organometallic reaction in which alkene is transformed into a cyclopropane system. Let's revise important concept. Diiodomethane and zinc copper couple are used for making a carbonate, and this carbonate is Simmon-Smith reagent, This Simmon-Smith is organozinc compound, which is important carbonate for generating a carbene like over here. So here this carbene has generated from the application of organozinc compound, which is electron deficient species. Once the carbene is generated, then it is added to the double bond for making a cyclopropane system. As far as stereochemistry is concerned, basically the carbon atom of carbene is sp2 hybridized. Two of the sp2 hybridized orbital are linked to two hydrogen or any other atom such as bromine or chlorine, and one of the sp2 hybridized orbital has a pair of electrons. All three sp2 hybridized orbital lies in the same plane, and there is one unhybridized sp or p orbital, which make the species electrophilic in character. The stereochemistry is stereospecific because the cis alkenes give a cis cyclopropane, and a trans species give a trans cyclopropane system. So this is all about a Simmon-Smith reaction. One important thing is that we have that the carbene must be generated first from a carbonate before it adds to a double bond. Thank you for watching the video.